Section 9.4. So we've been talking about the idea of a mathematical system. Then we took that idea and built upon it to particular types of mathematical system called groups and commutative groups. And so this last section, while it might not seem like it fits with the stuff we've been talking about, matrices, they are a mathematical object, and they do form, you can use them to form a mathematical group, a commutative group. We're not going to go so far into that aspect of it, but they are also handy if any of you are going to take any sort of business classes. I don't know where your mathematical future takes you after this, but matrices pop up in some different places when you have to maybe report a lot of data, or you have to do some modeling or anything like that. So being able to work with them and in the basics is going to be good. So first thing I want to just let you know is what a matrix is. So a matrix, it's not just the Keanu Reeves movie. Matrix is a rectangular array of elements. Okay, and so you can see, spoilers, when you look down the page, you can see these bracketed things that have different numbers of rows and different columns, and there's numbers in the different places. Those are examples of matrices. Okay. So when we label a matrix, we label it M. Using numbers, we label it M by N, and an M by N matrix means it has M rows and N columns. So when we talk about matrices, that's how we label them depending on how many rows and columns that we have. So for instance, matrix A right here that we're going to do a problem with in just a minute, that would be a 3 by 2 matrix. It has 3 rows and 2 columns. So this is a 3 by 2 matrix. As opposed to, if you look down a little further in example 2, okay, that is now a 2 by 3 matrix. So it has 2 rows and 3 columns. So this one is a 2 by 3 matrix. Being able to identify how many rows, how many columns, that's going to be handy when we go to talk about the very last operation of matrices that we're going to talk about, which is multiplying. Okay, so that's how we refer to matrices when we're talking about them, by the number of rows and columns. That's how we label them. And then the last thing is 2 matrices are equal. We call 2 matrices equal if and only if they have the same elements in the same positions. Okay, seems like kind of an obvious thing, and you're probably right, it is pretty obvious. So since it's so obvious, I'm not even going to do an example. What I would like you to do, please, is in exercise 1, I want you just real quick, write down the values of x, y, and z that create for us 2 equal matrices. All right, so what's the value for x that we got to put in there?
11.
Yep. It's just as simple as noticing that 11 is in this position right here, the first column in the second row, and then that's where the x is, and so that's why it's 11. The value of y is going to be 2, and then the value of z is -8. Great. I hope that was a nice and pleasant experience for you to identify the two matrices being equal. So far, so good. Are we all up to speed? We doing all right? So what we're going to spend our time with today, and we're not going to talk about equal matrices anymore because that was just very much in your face. We're just going to talk about 3 operations with matrices. We're going to talk about adding and subtracting and multiplying them. There's a lot of other things that you can do with matrices. There's a whole branch of algebra that is the algebra of matrices. It's called linear algebra. It's a lot of fun, but that's not what we're going to do. We're just going to do some basic operations. So when we go to add and subtract matrices, I'm down in example 1 right now. So when you add or subtract, here is something to note. You can only add and subtract matrices that have equal dimensions. Okay, so you have to have corresponding values to add. So I'm just going to write they must have the same dimensions. That's not going to be true for multiplication when we get there. In fact, multiplication, sometimes when you have matrices with the same dimensions, you can't multiply them. So we'll have to talk about that. But once you identify that, once you have two matrices that have the same dimensions, adding them is just as simple as adding the corresponding positions. So for instance, in example 1, when I go to do A plus B, I'm just going to write A plus B right here and an equals. I'm going to put a bracket, and I'm just going to go position by position. So row 1, column 1, 5 plus 2. That's going to give me 7. And then row 1, column 2, 6 plus 8, that gives me 14. 2 plus 4 gives me 6. And finally, -3 plus 0 gives me -3. And there's my result matrix right there. It's a 2 by 2 matrix because both of the ones that I started with were 2 by 2. Questions, comments, concerns about adding two matrices together? All right, well, please, as always, this is not a super long section. We're going to have some time at the end if you have some questions about the unit in general. So ask what you got, because I want you to do amazing on this test that you're going to have on Wednesday. So please do exercise 2. Add those that are both 2 by 3 matrices. Okay, so for this one, A plus B, again, if you're still working, keep working. I'm not trying to rush you. I'm just trying to make sure I'm splitting the difference here. I'm just going to add the corresponding positions. So row 1, column 1, 3 plus -8 is -5. Row 1, column 2, -2 plus 5 is 3. And then row 1, column 3, 4 plus 6 is 10. Notice I'm not putting any commas between things. So if you're using commas to separate the elements, that's not what you would do for your matrix. You just put a little space there to indicate that you're in the next row or the next column. Okay, so just keep things a little bit separate so that you can discern between the different numbers, and that's all you do for your matrices. So row 2, column 1, -5 plus 13, that's going to turn out to be 8. Row 2, column 2, 6 plus -3 is 3. And then last but not least, 12 plus 7 is 19. Did I do my addition all right? Anybody get anything different? I'm sometimes careless. Let me know. All right, well, if you feel good about that, then continue. Please do exercise 3. Got two 3 by 3 matrices now.
So it's negative, it changes the sign of everything.
We'll get there. We'll get there. All right, so just going through this, 14 plus 6, that's 20. That's my first element. 10 plus -3 is 7. And then -7 plus -2 is -9. And there is row 1. Row 2, 3 plus 4 is 7. 5 plus 8 is 13. And then -9 plus 5 is -4. There's row 2. And last but not least, 0 plus 6 is 6. 9 plus 3 is 12. And -1 plus -2 is -3. And there's my 3 by 3 result. So with adding Both matrices have to have the same dimensions. The result matrix has the same dimensions. And I think you probably could guess subtraction is going to be much the same. So for my example 2, I'm going to subtract the matrices that I used in example 1. So I'm just going to write that down. And then there's a question that's out there that was asked, and it's a great question. It's about procedure. So I've got 5, 2, 6, negative 3. I'm going to subtract matrix B, which is 2, 8, 4, 0. Now you can do this one of two ways. I'm not bothered either way you want to do this. Just do what's best for you, and it's going to get you a correct answer. If you feel like you are going to struggle with this minus sign and remembering to apply it to every one of the elements in the other matrix, then what I would recommend you do is I would recommend distributing that through the matrix. And we'll talk about multiplying a little more in just a minute. If that is not necessary for you and you feel totally confident in your ability to subtract all the pairs of elements, then that's fine. So I'm just going to go ahead real quick and distribute because I am not confident. So for me, the first matrix is going to stay the same, 5, 2, 6, negative 3. And then I'm going to change this to a plus because I'm going to distribute the negative. Okay, so a negative, when I apply it to all of these, gives me this. And now I'm ready. Now it's just adding, it's just combining the terms in the appropriate places like we did before. So 5 and negative 2, or 5 minus 2 is 3. That's the first position. 6 plus negative 8, or 6 minus 8 is negative 2. 2 minus 4 is negative 2. And negative 3 minus 0 is negative 3. And there's my result matrix. All right, so I'm not meaning to confuse anybody. If that's too much work for you, then go ahead and just do it one by one. So on the top of the next page, exercise 4 says you just ask for you to subtract A and B from exercise 3 on the previous page.
Exercise 2.
Exercise 2, exactly. I was reading what was on the screen rather than what was on the paper. So once again, I'm subtracting. I'm not going to distribute this time. If you did, that's fine. We're going to end up with the same thing. So I'm going to apply that minus sign, that negative to everything. So my first position, I have 3 minus negative 8. Well, when you subtract the negative, what do you get? Yeah, you get a positive. 2 negatives make a positive. So again, you got calculators. So hopefully the arithmetic is not something that's too intimidating. So 3 minus negative 8 is 3 plus 8. That's 11. Negative 2 minus 5 is negative 7. 4 minus 6 is negative 2. And there's my first row. Then the second row, negative 5 minus 13 is negative 18. 6 minus negative 3 becomes 6 plus 3, or 9. And then 12 minus 7 becomes 5. Any values there that we have to talk about? Any questions that you have? All right, well then do the next problem. It says do A minus B again. This time you're doing it for the exercise 3, the 3 by 3 matrices. All right, I'm just going to get started with my subtraction. Keep working if you're working. So 14 minus 6, I'm going to start out, that's 8. 10 minus negative 3 is 10 plus 3 or 13. Negative 7 minus negative 2 is negative 7 plus 2 or negative 5. Row 2, 3 minus 4 is negative 1. 5 minus 8 is negative 3, and negative 9 minus 5 is negative 14. Last row, 0 minus 6 is negative 6, 9 minus 3 is 6, and negative 1 minus negative 2 is negative 1 plus 2 or 1. And there's my 3 by 3 result. We still doing okay? Just be careful. Really, on the test, students have no problems in the past. It doesn't seem to be a major issue adding and subtracting, with the one exception of if you kind of bumble the signs a little bit. So just take your time, make sure you apply that subtraction to everything. Same thing applies here. This is example 3. So now what this notation means is whatever matrix A is, I'm going to multiply that by 3. And then whatever matrix B is, I'm going to multiply it by 2 or by negative 2 since I'm subtracting. What these numbers are called, when you just have a coefficient in front of a matrix, it gets a fancy word because math people like to just be fancy sometimes. This is called a scalar. Okay. I'm not going to try to trick you with any vocabulary. Just want to let you know that your math professor does know the word, so I'm proud of myself. Okay, so now what we're going to do is I'm just going to rewrite the problem, and then we'll do our multiplying and we'll do our adding. So going back to the previous page, I'm going to have the number 3. Now this is not a matrix. That's why the mathematicians have named it a fancy thing called a scalar. Don't confuse this. It's not a little matrix. It's just a plain old number out in front. So I've got 3 times matrix A from this example, which is 5, 6, 2, negative 3. And then minus 2 times matrix B from that first example, which is 2, 8, 4, and 0. Now, I know some of you are probably capable of doing more in your head than I am, and that's fine. Just please make sure, especially on the test, there's no rush, so there's no reason. I don't give bonus points for doing stuff in your head. Just make sure you're doing it accurately. That's the most important thing. So what this scalar does, what this 3 does, it says, okay, multiply each of the things in the matrix by 3. So this matrix becomes 15, 18, 6, negative 9. And then I'm going to add to this, and I'm going to multiply that whole negative 2 by that. That's why I changed it to an addition. So I've got negative 4, negative 16, negative 8, and 0. Anybody confounded about where any of those values came from in either of those matrices? Okay, now it's just adding. Okay, no one's made a peep about adding. I'm hoping that that's very obvious. 15 plus negative 4 is 11. 18 plus negative 16 is 2. 6 plus negative 8 is negative 2. Negative 9 plus 0 is negative 9. And there's my answer matrix. Yes. How did I get the which one? I'm sorry. Because I distributed the negative along with the 2. Okay, so if I left it as a subtraction, then I would be changing the problem because I'd be subtracting and I already multiplied by the negative 2. So just to remind myself that I'm just combining the individual elements, when I distributed this whole thing right here, I just changed it to an addition to remind me. The rule for subtraction, if you remember your arithmetic like eons ago, instead of subtracting, we call it adding the opposite. And so that helped us rewrite subtraction problems in terms of something that we know how to do. So if you wouldn't mind, please, exercise 6, you're going to use the 2 by 3 matrices that we used at the top of this page. So while you're doing the problem, I'm going to rewrite it as well. I'm going to get started on this problem. So my first matrix, when I multiply by 2, is going to become 6 and -4 and 8 and -10 and 12 and 24. It's a plus problem. I'm multiplying by a +4. So I've got the second one is -32 and 20 and 24, and 4 times 13 is 52, I believe, but you should definitely double check the Perkster. And then 4 times 7 is 28. And then I didn't leave myself, I wrote my original matrices too big, so I'm just going to try to squeeze it in right here. My result, 6 plus -32 is -26. -4 plus 20 is 16. 8 plus 24 is 32. -10 plus 52 is 42. 12 plus -12 is 0. And then 24 and 28 turns out to be, I think, 52, but I can't talk and add, so you should definitely check that. Yeah, all right, great, good for me. All right, just one more, again, because this is a super short section, just please notice I flipped the order of the matrices, so it's 5b minus 3a. Okay, so make sure you're putting the right matrix in the appropriate place. Yeah.
Can you ever do these type of things with like an ABC matrix?
Oh, you definitely could.
Okay.
But since this isn't an algebra class, we're not. There are lots of fun things you can do with matrices. There's things called the transpose of a matrix. You can find the identity matrix. You can use, if you really wanted to have some fun, you can use matrices to solve systems of equations. If this was an algebra class, these are like super useful things.
So like if you're a big data company like Amazon or something like this, you're using like a lot of this stuff to sort large packets of data type deal?
Yeah, and to also combine it, you can use matrices because when we talk about multiplication, gives you a way to merge things together. So yeah, there's lots of data applications to matrices. Sure. Okay, so there's lots of numbers there. So I've set up my original problem. Notice 5 times the B matrix. Okay, so make sure you got the right matrix in the right place. -3 times the A matrix. I'm going to multiply the negative and the 3 all the way through. So that's going to take care of my subtraction. So again, in case you're wondering why I made it into an addition problem over here, it's because I've already taken care of the subtraction by distributing the negative. And so I'm just going to real quick read just in case you're having trouble seeing because this orange is a little funky. The top row is 30, -15, -10. And then the second row, 20, 40, 25. The last row is 30, 15, negative 10. The second matrix is negative 42, negative 30, 21, negative 9, negative 15, positive 27, 0, negative 27, and positive 3. And so now my result matrix is just going to be what I get when I add these things up. So 30 and negative 42 is negative 12. Negative 15, negative 30, that's negative 45. Negative 10 and 21 is 11. 20 and negative 9 is 11. 40 and negative 15 is 25. And 25 and 27 turns out to be 52. Finally, 30 plus 0 is 30. 15 and negative 27 is negative 12. And then negative 10 and 3 is negative 7. And we got it. We squeezed just enough room out of that. Again, any issues or concerns with the arithmetic? All right, well then we're going to finish this section and our brief discussion of matrices by talking about how do we multiply two matrices together. So in order to multiply two matrices, it's a different process than adding and subtracting. So whereas adding and subtracting, just to remind you, the matrices have the same exact dimensions. For multiplying, the number of columns of the first matrix has to equal the number of rows of the second. So the number of columns of the first has to equal the number of rows. So for instance, what that means is if I have a 3 by 2 matrix, okay, so remember that's 3 rows by 2 columns. And then I'm going to multiply that by, well, the next matrix has to have 2 rows. The number of rows of the second matrix has to match the number of columns. So I could multiply by something like a 2 by 5 matrix. Okay, so tried to be clear at the beginning, and it's important when you label your matrices, it's rows by columns. Okay, that's always the order that you're going to be given. If I tell you something is a 5 by 2 matrix, it means it's 5 rows by 2 columns. And so with that, these interior numbers need to match to multiply. This is the number of columns of the first matrix. This is the number of rows of the second matrix. Those two things have to match. All right, so with that said, you are ready. We are going to multiply a pair of matrices. So my first example, example 4, we are going to multiply A and B. So I'm going to rewrite the problem. I'm going to rewrite the matrices next to each other so that I can do some stuff. So here we go. So I'm going to multiply A and B. So I've got 3, 1, 4, negative 2, and then I've got 5, negative 1, 3, 2, 8, 0. So as you write those down, as you write them next to each other, I want you to just observe and answer this question. Can you tell that the number of columns of the first one matches the number of rows of the second one? So here, this one has 2 columns, right? And then the second one has 2 rows. Okay, that's important. So then the question is, once you've identified that, what does it mean to multiply 2 matrices together? And that is a great, great question. I'm going to take this slow, okay, because this is more difficult, okay, than adding and subtracting, just to prepare you. It's not impossible. I feel like everybody here is going to be fine doing it eventually. But remember, just ask whatever questions you need to as we go along. So here goes. What you do, okay, the reason the number of columns has to match the number of rows is you're going to take this first row right here, and what we're successively going to do is we're going to multiply it by each of the columns. So I'm just going to circle the first one. So we're going to multiply by this first column. So I'm going to take the 3 and the 1 of the first matrix, and I'm going to multiply it by the 5 and the 2. Now I'm doing a lot of writing. If you don't see where these numbers come from, let me know. But here's what we do. We're just going to follow like this. I'm going to take the 3 times the 5. I'm going to take the first. So 3 times 5 is 15. plus, then I'm going to move and I'm going to multiply the 1 times the 2. The 1 times the 2 is 2. So we'll come back in a minute and we'll combine those, but I multiply those individual positions and then I add up what I get. So again, what did I do here? I did the 3 times the 5 and got 15, and then I moved to the next element, the 1 times the 2, and got 2, and I'm going to add those two numbers together. And hey, Perkster, how do I know where to write that? Another great question. Where you write it is, this is the first row, this is the first column. So it becomes the first row, first column of your answer. What we're going to do now is we're going to take that 3 and that 1, and now we're going to move to the next column, and we're going to multiply it by the -1 and the 8. And again, where am I going to write my answer? I'm going to write my answer. This is the first row. And now we're in the second column. So I'm going to put my answer in the first row, second column. So once again, here we go. I'm going to multiply the first, the 3 times the -1. What's 3 times -1? Okay, -3. And then plus, now I'm going to move to the seconds. What's 1 times 8? Okay, 8. So the next term, the next position is going to be -3 plus 8. And we'll go back in a minute and we'll do that addition. Okay, I'm just trying not to do too many things all at once. And then last but not least, I'm going to take that 3 and that 1, the first row, and I'm going to multiply by the last column. And if this was a 2 by 10 matrix, I would just keep doing every successive column until I was done. Okay, so now I'm going to take my 3, 1, that row, multiply by the 3, 0 column. So first, 3 times 3 is going to be 9 plus. Now I'm moving to the next elements. 1 times 0 is 0. All right, that's the first row, the 3 and the 1 row times each column. Then what you're going to do, and I'm going to give you 60 seconds or so. I want to see if you can do this, okay, because this is how we're going to learn. What you're going to do now is we go back to the beginning, and we're going to go, okay, I'm going to do the same thing with the 4, -2 row. I'm going to take this second row, and I'm going to multiply by each of the 3 columns and write my answer in each of the 3 columns. So give that a try. Give it your best shot. Okay, again, this is a difficult process. So if you get a different number, or if you don't see why I'm multiplying things, that is a great opportunity to ask a question as we learn this. So I'm going to take this second row. I'm going to go through each column. So again, the 4 times the 5, that's going to give me 20. Plus, now I move to the seconds. The -2 times the 2 is a -4. I'm going to take that second row and I'm going to multiply by the next column. So the 4 times the -1, that's -4 plus. Then I move to my seconds. -2 times 8 is -16. Then times the third column. 4 times 3 is 12 plus -2 times 0 is 0. All right, that's the hard work. Once you've done that, the rest of this is just mopping up and doing those addition problems. So the first position now, 15 plus 2 is 17. -3 plus 8 is 5. 9 plus 0 is 9. 20 plus -4 is 16. -4 plus -16 is -20. And last but not least, 12 plus 0 is 12. And there's my result matrix. All right, so the first one that you're going to endeavor to do all the way through, exercise 8 says, go back to the first page, that very first example that I did of the two 2x2 matrices, go ahead and multiply those together. All right, I'm going to start this one a little quicker than the others just because this is a difficult thing to learn and catch on to, and I totally get that. So again, what your general process is here is I'm going to take this first row and I'm going to multiply it by each of the columns of the second one. You don't have to write these circles down. I'm hoping that that is something that's a little more helpful when you're looking at it. So here we go. I'm going to take that first row. So since I'm in the first row, first column, my answer is going to be first row, first column. So here we go. The 5 times the 2 is 10, plus the 6 times the 4 is 24. Now I'm going to take the first row times the second column. The 5 times the 8 is 40, plus the 6 times the 0 is 0. Okay, there's all my positions. I'm done with the top row. There's no other columns to multiply it by. So now I'm going to move my attention down to the second row. And so now I'm going to be in the second row with each of these columns. So 2 times 2 is 4, plus 3 times -4 is -12. And then the second row, second column, 2 times 8 is 16. And then -3 times 0 is 0. So my result matrix, again, is 2 by 2. 10 plus 24 turns out to be 34. 40 plus 0 is 40. 4 plus -12 is -8. And last but not least, 16 plus 0 is 16. So there is my result. All right, next one. Save you a little work on this one, since my B matrix is a 2 by 1. Okay, so you can multiply it. So all I've got is one column you're going to multiply each of these things by. So you've got 3 rows you're going to go through, and then you got one column. That's going to be your result. I'm sorry, what? Oh, yeah, sure is.
That makes sense. Like,
With what are you asking that?
like, that's supposed to be going downward.
Yeah, you're gonna go downward because this is the first row, and then you're moving down to the second row, and then you're moving down to the third row. So that's why you're gonna move down the rows. Great question. Okay, so on this one, just to get us a little more practice, but to kind of make this a little bit of a shorter problem, what we've got here is I'm going to take this top row and I multiply. I've only got one column. Okay, so when I go ahead and do this now, my result is just going to be one column because that's all I got. So the question that was asked to me, in case you didn't hear, is, hey, Perkster, when I'm doing my result, do I go down or do I go to the right? And the reason you go down is because this is first row, first column, and then this will be second row, first column, and then this will be third row. So that's why I just keep going down to the next successive row. Okay, great question. So here we go. So I'm going to take the 1 and the 0 times the 2 and the 5. So 1 times 2 is 2, plus 0 times 5 is 0. I'm going to go down to the next one. I've got 4 and negative 2 is the next row, times 2, 5. So 4 times 2 is 8. Negative 2 times 5 is negative 10. And then last but not least, I've got my last row times the column. So negative 1 times 2 is negative 2. And then plus 3 times 5 is 15. And so I've got a 3x1 matrix. 3x1 matrix. I've got 2 is the first entry. I've got negative 2 is the second. And then 13 is the third. There we go. All right, the next one's kind of the busy work problem for the day. It'll be the longest one. You're going to end up with a little bit of a larger matrix. So give this one a try. Give you a couple minutes to chew on this as much as you can, and then we'll do it together. All right, I'm going to get started on the busy work. If you're working, keep working. So again, I'm going to start with this top row, first column. So top row, first column, 2 times 5 is 10. And then -1 times 1 is -1. Then I'm going to move top row. I'm going to move to the second column. So 2 times 3 is 6, plus -1 times 0 is 0. Then I'm going to go top row, third column. So 2 times -4 is -8. And then -1 times 3 is -3. And then top row, fourth column. So 2 times 2 is 4. And then -1 times -1 is +1. So I went each successive column. So I went each successive column in my answer. Now I'm going to move down to row 2. And as I as I multiply row 2 by each column, I'm going to be in row 2 of my answer in each successive column. So 3 times 5 is 15. -2 times 1 is -2. Then I go to column 2. 3 times 3 is 9. And then -2 times 0 is 0. Then the third column, 3 times -4 is -12. And then -2 times 3 is -6. And last but not least, 3 times 2 is 6. And then -2 times -1 is +2. And there's my second row. And then I'm going to do the very same thing for the third row. I'm going to take this third row times each of the 4 columns. So 4 times 5 is 20. And then 1 times 1 is 1. Second column, 4 times 3 is 12. 1 times 0 is 0. Third column, 4 times -4 is -16. And then 1 times 3 is 3. And then 4 times 2 is 8. And 1 times -1 is -1. So that's a lot of entries. You got yourself a 3x4 matrix there at the end. So 10 plus -1 is 9. 6 plus 0 is 6. -8 plus -3 is -11. 4 plus 1 is 5. Almost wrote 4, but I caught myself. 15 plus -2 is 13. 9 plus 0 is 9. -12 and -6 is -18. 6 and 2 is 8. And last but not least, 20 plus 1 is 21. 12 and 0 is 12. -16 and 3 is -13. 8 plus -1 is 7. And there we go. So rather than the last problem that's there, I mentioned earlier that that matrices have the potential to form a group. So if something was a group, it would need an identity. So just real quick, instead of exercise 11 as written, go ahead and do this problem right here. Take matrix B, which is 8, -4, 2, and 3, and multiply it by this matrix right here. 1, 0, and then 0, 1. And let's see what we get. All right, so on this matrix, I'm going to take my top row. I'm going to multiply it by each successive column. I'm just circling the first one so that I get the pattern, what's going on here. So here goes. I'm going to take 8 times 1 is 8, and then -4 times 0 is 0. Then I'm going to take that top row and do column 2. So 8 times 0 is 0, and then -4 times 1 is -4. Then I'm going to move to row 2. So row 2 times the first column. 2 times 1 is 2. And 3 times 0 is 0. And then last but not least, 2 times 3, excuse me, 2 and 3 times 0 and 1, 2 times 0 is 0, and then 3 times 1 is 3. And what do you notice is the result when I do this? I get the same matrix that I started with, right? So this would be, for multiplication, this would be my multiplicative identity. So that's good for square matrices. So we're not going to talk about it in more detail, but since in not all situations is matrix multiplication commutative, what you would technically call this is the right-handed identity, because we multiplied on the right side of the matrix. So for the square matrix, the right-hand identity would be the same as the left-hand identity, but that wouldn't be true for all situations of matrix multiplication. But that's more detail than you need. I just want you to be impressed with the Perkster today. So that is that.